Yeah, welcome back everybody. Today we're solving questions on sets and we're using the Venn diagram. Before we go to the questions, let's get this straight. If I have two sets A and B, I represent two sets A and B using the Venn diagram this way. Let me use a classroom for example. Let's say in a class of 50 in a class, let me just say in a class, this rectangle will represent the class, and that's a universal set. Let's say A is a set of students who like mathematics and B is a set of students who like physics, who like English rather. A is a set of students who like mathematics, and that's what this first circle represents, while B is the set of students who like English, which the second circle represents. Now, the whole of this circle represents the number of students who like mathematics. So that means this place alone, let me use different colors, this place alone, where I'm shading in purple, represents those that like only mathematics, while these parts I'm shading in yellow represents those that like both mathematics and English, and this part that I'm shading in green represents those that like only English, because we can see that there's nothing like mathematics in it. So if we want to represent this in set notation, I would say I want to use set notation to represent them, to represent those parts. This place is only math, so I'll call it A intersection. This place is only math, that's A intersection B complement. This place is both math and English, so it is A intersection B. And this place is only English, so I'm going to represent it in set notation. Write it in set notation as A complement intersection B, because it is only English. So if I write N A intersection B complement, that means the number of elements in the set A intersection B complement, which simply means the number of students who like only mathematics. If I write N A intersection B, that means the number of elements in the set A intersection B, which means the number of students who like both math and English. And if I write N A intersection B complement, that simply means the number of elements in the set A intersection B complement, which means the number of students who like only A complement intersection B rather, number of elements in the set A complement intersection B, which means the number of students who like only English, or you can say number of students who like English but not mathematics. So that's what all of that, that's what that means. I think I'm going to leave that as we move on, so that when we start using it to solve questions, it will be easy to represent whatever we want to represent using set notation. This is symbol for intersection, and the number of elements in a set is simply the same as, it's simply called the cardinality of that set. So let's go straight to the questions. Number one, in an examination, 18 candidates passed mathematics, 17 candidates passed physics, 11 candidates passed both subjects, and 1 candidate failed both subjects. By the way, this part, which is the part inside the rectangle but outside the two circles, is a region that represents the number of candidates who do not like any one of mathematics and English. So that is written in set notation as A union B all complement, or you can also write it as A complement intersection B complement. So the number of elements in it will now be written this way, which means the cardinality of the set A union B all complement, or the cardinality of the set A intersection B complement, A complement intersection B complement, and that will represent the number of candidates who don't like any of the two subjects. That's why it's always written outside the circles. So they are in the class, but they do not like any of the two subjects. So let's go straight to the questions. In our examination, 18 candidates passed mathematics, 17 passed physics, 11 candidates passed both subjects, and 1 candidate failed both subjects. Let's represent that first of all. Let this be the set of candidates who passed physics, and the second set will be the set of candidates who passed. No, first set will be the set of candidates who passed mathematics, and the second set will be the set of candidates who passed physics. Now, while this, we are making this the class, the entire class, which is the universal set here. Now that's it. We don't know the number of elements in it, so I'll just call it U. This will be number of candidates who passed math. That's 18. That simply means the number of elements in the set M. If I write P for the set of students who pass physics, that means the number of elements in it, it's 17. I'm using P to represent the set of students who pass physics. Now they said 11 passed both. That will be here. The region that's common to both circles is going to be the set that represents the intersection of the two sets. So that's it. Now 1 candidate failed both. That's going to be outside the two circles but inside the rectangle, because that candidate is also a member of a class, but he didn't just pass. He's also one of the candidates that took the examination, but he didn't just pass any one of the two subjects. Now the first question says find the number of candidates that passed mathematics only. That's simply the number of elements in this region. That's where you can see only math. So that simply means math only. I can write it as M intersection P complement. This is a set notation for the set of candidates for the number of candidates who passed math only, and that will be, we know that everything inside this circle is 18, and this part is 11. This part is 11. This part is 11. That simply means this part is going to be 18 minus 11. So number of elements in the set M intersection P complement is going to be 18 minus 11, and that's 7. So that means mathematics only, number of candidates who pass mathematics only is 7. 7 candidates pass mathematics only. Now to the second. The second question is number of candidates that passed physics only. That's the whole of this place. That's what this region represents. That's only physics, and that's going to be number of students. The whole of this is 17, and we know this part to be 11. That means the remaining part is going to be 17 minus 11. Physics only. You might like to see that as we work it out. That's a tiny image of it. So number of candidates who pass physics only. Let me just write. That's actually, if I write that in set notation, it's going to be N number of, this is how I write it. No math means M complement intersection P. That means it's only physics, and that is 17 minus 11, which is 6, which means 6 candidates passed physics only. So I can say therefore physics only is 6. Now to Roman figure 3, and that's total number of candidates that sat for the examination. That's everything inside the Venn diagram, which is number of candidates who pass only math, that's 7. Number of candidates who pass only physics, that's 6, plus number of candidates who pass both, and number of candidates who passed none, who failed both. So total number of candidates, that simply means the number of elements in the universal set, which is the same as the cardinality of U, if you like. So total number of candidates is going to be 1 plus 7 plus 11. Let me paste that diagram again. That's the image here. So this place is 7, this is 6, and this is 1. So total number of candidates will be 7 plus 11. Those that passed only math, 7, plus those that passed both, 11, plus those that passed only physics, plus those that didn't pass any of the 2 subjects. And that's simply 18 plus 6, 24 plus 1, 25. So that's it, very, very simply. We go straight to the next, which is number 2. In a party for 30 young children, 12 were served with Coca-Cola drink, while 14 were served with Pepsi-Cola. If 9 children were served with Coca-Cola but not Pepsi-Cola, find the number of children served with both drinks. Okay, let me go to that the same way. Let this represent the set of children who were served with Coca-Cola, and this represent the set of children who were served with Pepsi-Cola, while this will represent the whole of the children at the party. So that's it. Here we know the total number of elements, elements in the universal set, or the total number of children at the party. Now this will be C for Coca-Cola. So number of children who were served with Coca-Cola will be number of children who were served with Coca-Cola, that's 12. So that means the cardinality of a set that represents Coca-Cola is 12. Number of children who were served with Pepsi-Cola, that's 14. 14 were served with Pepsi-Cola. So now if 9 children were served with Coca-Cola but not Pepsi, that means only Coca-Cola, which is this place, that's 9. If I write that in set notation, it's going to be C intersection P complement. That means the cardinality of that set C intersection P complement is 9. Now they are saying we should find the number of children served with both drinks. That is this place, which is what is common to the 2 sets. That means the people here drank the 2 drinks, were served with the 2 drinks. So I'm going to say let number of students who were served with both drinks, which is the same as the set C intersection P, be equal to X. That means this place is X. So if I want to find X, I already know that the whole of this is 12 and this is 9. That means 12 minus 9 is what will give me X now. So X equals 12 minus 9, and that's 3. Therefore, children served with both drinks, number of children served with both drinks, number of children served with both drinks. I don't think I need to write that story. Therefore, number of children served with both drinks is 3. Now to the next. Homework figure 2 says, number of children served with at least one type of drink. Now this is a trick. The number of children served with at least one type of drink is the same as the whole of at least one type of drink. Okay, that means number of children served with only Coke plus those served with both Coke and Pepsi, plus those number of children served with only Pepsi. So that's the total number of children who were served with drinks, whether only Coke, both Coke and Pepsi, or only Pepsi. That's what it means. And in set notation, that's the same as C union P. It is the total number of elements inside the whole of the 2 sets put together. And the whole of the 2 sets put together is the same as C intersection P complement, which is Coke only, plus C intersection P, which is Coke and Pepsi, plus C complement intersection P, which is Pepsi only. That's what it means. And since they didn't say that there was any child who didn't drink any one of the 2 drinks, that means there's nobody outside the 2 circles inside the rectangle. So the cardinality of C union P is now going to be, but I need to find this one first. I need to find the number of children served with only Pepsi first, and that's going to be 14 minus X. So before I can find N union, number of elements in the set C union P, I need to find this first. Number of children served with only Pepsi. In set notation, that will be C complement intersection P, and it is 14 minus X. I know the whole of this is 14, and this one is X. That means this is going to be 14 minus X. So I already know X to be 3. That simply means 14 minus 3, which is 11. So I can now find total number of children served with any one of the drinks. No, number of children served with at least one type of drink, which is going to be 9 plus X plus 14 minus X, and that means 9 plus 3 plus 11. 9 for those served with only Coke, X which is 11 for those served with, X which is 3 for those served with Coke and Pepsi, and 14 minus X which is 11 for those served with only Pepsi. So that's 9 plus 3 plus 11, and that is the same as, that's 12 plus 11, 23. So the total number of children served with at least one type of drink is 23. Now to Roman figure 3. Roman figure 3 says the number of children not served with any of the drinks. Okay. Oh, we were not told that there were children who were not served with any of the drinks, so we don't assume. We just know that number of children served with at least one type of drink is the same as the total number of elements inside the whole of these two sets, which is a combination of those who drank only Coke, those who drank Coke and Pepsi, and those who drank only Pepsi. That's all. It doesn't mean that there can be children who were not served any drink, as this question implies. The number of children not served with any of the drinks. Now 23 children were served with either Coke or Coke and Pepsi or only Pepsi. So a number of children served with none of the two drinks, which will be here, that set is set C union P all complement, or if you like you can write it as N of C complement intersection P complement. I'm choosing this one to show that it is not in the two of them put together. So number of elements in the set C union P complement is going to be, if I know that 30 is the total number of children at the party and 23 were served either Coke and Pepsi or only Pepsi, that means those that were not served any will be 30 minus 23, which is 7 obviously. So number of children not served with any one of the drinks, is 7. So that is just as simple as that. Number 3 says a survey was carried out on 40 travelers. 12 of the travelers said they had traveled to Ghana but not Cameroon before. 8 of the travelers claimed they had traveled to Cameroon but not to Ghana before. 10 of the travelers said they had not traveled to any of the two countries before. Draw a Venn diagram to find the number of travelers that had traveled to both countries before. 2, the number of travelers that had traveled to Ghana before. Okay, so let's go. Let this circle represent the number of travelers who had traveled to Ghana before, and this one, I think I should just copy it. Oh, let me just duplicate it here, and this will represent the number of travelers that had traveled to Cameroon before, while this rectangle will represent the total number of travelers, or the total number of people, involved in the survey. So that's a universal set. We don't know how many they were. Okay, we know the number of elements in the universal set is 40 because the survey was on, the survey was on 40 travelers. So this will represent the number of travelers who had gone to Ghana, G for Ghana, and that's 12, and C for Cameroon. Number of travelers who had gone to Cameroon before, and that is, I don't think I'm doing the right thing. Let me read that again. 12 travelers said they had gone to, 12 of the travelers said they had traveled to Ghana but not, said they had traveled to Ghana but not to Cameroon before. That means, let me just call this G. I don't know the total number of travelers who have traveled to Ghana, and neither do I know the total number of travelers who have traveled to Cameroon. That's why I'm not writing this, because if I write this, that means I know the number of elements in the set. I'm just calling it set G for those who had gone to Ghana and C for those who had gone to Cameroon. Now they said 12 had gone to Ghana but not Cameroon. That means Ghana only. That's this place. The people here. You can see it doesn't contain Cameroon at all. So that's 12. In set notation, that's the same as G intersection C complement. They had gone to Ghana but not Cameroon. 8 of the travelers claimed they had gone to Cameroon but not to Ghana. That's this place. Cameroon only. You can see there's nothing like Ghana in it. So that's 8. In set notation, that will be number of elements in the set, G complement intersection C, and that's 8. Now, 10 of the travelers said they had not traveled to any of the two countries. That is, those that will be in the rectangle but outside the two sets. They are members of, they are also amongst the people on which the survey was carried out, but they hadn't gone to any of the two countries. That's 10. And now, okay, draw a Venn diagram to find the number of travelers that had traveled to both countries. So let that be X. I'm calling, let number of elements in the set G intersection C, which represents the number of travelers who had gone to both countries before, Ghana and Cameroon. Let that be X. Now, how do I find X? Of course, I know that those 12 plus X plus 8 plus 10 is going to give me 40. That's how I'm going to find X. So if you add everything together, I'm going to get 40. So 12 plus X plus 8 plus 10 will give me the total number of people on the survey. So that simply means 12 plus 8 is 20. Let me write by the X properly here. 12 plus 8 is 20 plus 10 is 30. That simply means X plus 30 equals 40, which means X equals 40 minus 30, and that means X equals 10. Therefore, 10 candidates had gone to both countries before, had been to both countries before. Now, Roman figure 2. Roman figure 2 says the number of travelers that had traveled to Ghana before. Those that had traveled to Ghana before will be all the people inside this set, which represents people who have gone to Ghana. So whether you've gone to, whether it was only Ghana they went, or they went to both Ghana and Cameroon, they are going to be in this set. That's what it means. Those that had traveled to Ghana is a sum of all the people who had gone to Ghana before, whether they went elsewhere together with the Ghana or not. And in this case, it's a combination of those who had gone to only Ghana and those who had gone to both Ghana and Cameroon. As long as they went to Ghana, they are going to be amongst the people in the set. So that simply means that's actually the cardinality of the set G, which means the total number of people who have gone to Ghana, or the total number of elements in the set G. And that's going to be 12 plus X, which represents those who have gone to only Ghana and those who have gone to both Ghana and Cameroon. And that's 12 plus 10, which is 22. So that's the total number of candidates, of travelers who have gone to Ghana before. Okay, let's keep that and then we continue in the next. Thank you very much, and you might want to subscribe to this channel for notifications when a new video is uploaded. God bless.